When I finished designing this robot arm, I thought the hard part was over, the CAD looked great, and I was thinking, all I left to do was print the parts and assemble them. Simple, at least that's what I thought, because over the next few days, I discovered CAD hide a lot of things. Tiny screws, parts that almost fit, servos that destroy themselves, and the robot arm seems to be determined to not exist. But somehow, by the end of this build, Pico Pal actually moved. Hi, this is Robot Amateur. I'm a robotics engineer and a robotics enthusiast. This robot arm is called Pico Pal. My goal is to build an affordable robot arm that beginners can build at home. In the previous video, I designed the first version in CAD. Today, we are building the very first version of this prototype and finding out what works and what definitely doesn't. Let's get started. The first surprise happened before assembly even started. I ran out of filament. Fortunately, I printed the parts one by one instead of everything at once. So instead of losing an entire print batch, I only lost a single part. Not a bad start. Soon enough, all the parts were printed. And that's when reality started teaching me lessons. This sounds ridiculous, but one of the hardest tasks was putting tiny M2 nuts into the servo mounts. I tried tools, I tried holders, I tried being clever. Nothing worked. Eventually, the solution was just trying again. And this is where I learned my first lesson. CAD completely distorted my sense of scale. When I'm designing, I zoomed in and out constantly. A tiny M2 hole can fill my entire screen. But in reality, it's tiny. Everything is much smaller than it feels inside CAD. Then I discovered another classic CAD mistake. I forgot to leave clearance between two parts. The cable cover and the arm were designed to fit tightly together. Too tightly. So for version 1, let's just use tape. Very advanced engineering. But this failure came with a small victory. I had already updated the shoulder version of the design.
This is quite nice.
And this time, it fits perfectly. Proof that iteration actually works. Next came the servo horns. The servo horn didn't quite fit. I probably should have added a little more clearance in the design. For now, I use the Dremel as a temporary fix. The part of the shoulder cracked twice. I had designed sharp corners without fillets, and those sharp corners became stress concentrators. Exactly the things that I explained to avoid in my last video. Now I was learning the lesson myself. So, super glue again. I didn't think this would be so hard. At this point, the robot was teaching me mechanical design lessons, one mistake at a time.
It's kind of getting together.
After many hours of assembly, eventually I got everything assembled. I finally reached the stage I had been looking forward to, wiring. Actually, maybe looking forward to isn't the right phrase.
I don't know which one is which one now.
The solution was very simple. Label everything. It made my life much easier later.
Cool. It was much harder than I thought.
And for the first time, it actually looked like a robot arm. Not just a CAD model, not just a pile of parts, a real robot arm. It was finally time to see if this robot would actually move.
So I just turned on the Raspberry Pi.
Nothing. The robot barely moved. One servo became hot, and I immediately knew this wasn't going to work first try. So instead of testing everything together, I started testing each joint individually. The gripper worked, the wrist worked, the elbow worked, the base worked, and every working joint gave me more confidence. Maybe this wasn't a complete disaster after all. And something interesting happened. When the robot was horizontal, the elbow moved much better. But when I stood it upright, its range of motion dropped dramatically. Gravity suddenly became a real design constraint.
It's not moving.
Then I tested the shoulder.
Hola, hola, hola. Okay. I really don't like this. Okay, let me put like this. Trying to see. I guess he was trying to reach 0, but he couldn't.
The sound you are hearing is not a healthy servo.
I guess this is definitely bad. Okay, I think I'll stop testing here.
I replaced the servo. I tested it outside the robot. Perfectly fine. Installed it again.
Oh my god, I think I broke some gear again. Oh my god. Okay, stop.
At that moment, it became clear it wasn't because the previous servo was broken. The servo joint itself needs a redesign.
Okay, this is my robot with the shoulder broken. The shoulder is not powered.
One of the most surprising discoveries came from a tiny screw. I tested the wrist joint with and without the extra support point, and visually the difference was huge. The loads became much more controlled. The joint behaved like an actual revolute joint. It's one thing to learn this in theory, and it's another thing to see it happen right in front of you. And that's exactly why building prototypes is so valuable. Another lesson came from testing. The base takes about 12 hours to print. Instead of reprinting the whole thing, I printed only a small section containing the servo mount. 1 hour later, I knew the design worked. That tiny test saved an entire day. And that's probably one of the most useful prototyping lessons I've learned during this project. When I started this project, I thought success meant building a robot arm that worked perfectly the first time. Now I realize that's not how robotics works. This prototype taught me much more than any CAD model ever could. I learned that assembly constraints are real design constraints. I learned that gravity changes everything. Looking back, I thought designing the robot arm was the hard part. Now I think prototype is where the real learning starts. Pico Pal V1 is far from perfect. Some parts cracked, some servo died, and the servo pieces are literally held with superglue. But it moved, and for a first prototype, I'm pretty happy with that. In the next video, we will redesign Pico Pal using everything we learned from version 1 and hopefully making something much better. Thanks for watching. See you next time. Bye bye.